All right, ladies and gentlemen, this is a chapter 4 quiz, and this is problem number 46, so-called cruise ship activities. Okay, so pause your video and read this problem. 46, read the problem. Okay, pause the video, read the problem. Okay, so as you probably have noticed by now, I have a certain format that I always use. I always say what is given, and then I'll say what is it we're supposed to find, and then I will have a discussion and then maybe another section that I call solution. Okay, the problems are a little bit different, but that's the basic format that I follow. So here we go. Here's what's given to us. The director schedules the activities. Here's the activities that he schedules. He has 4 movies. He has 2 bridge games, 3 tennis games. Okay. Now, how many activities are there altogether? There's 4 plus 2 plus 3. There's 9 activities. There's 9 activities altogether. The couple selects 3 activities, and we want to find out the probability that the couple selects exactly 2 movies and 1 tennis game. So out of these movies, we pick 2 of the movies, and out of these 3 tennis games, we pick 1 game, and we don't pick any bridge games. Okay, so obviously nobody gives a crap about this exact problem, right? But it's a metaphor for other types of problems that would be a lot more interesting. Okay, so here's the page of some formulas that you're going to need. That's at the end of chapter 4. I urge you to make copies of these because they're very, very useful. Okay, so let's take a look here. We are going to use the following concepts. We're going to use the multiplication rule. That's on page 213 of the textbook. The so-called classical probability formula, which is on page 189. And we're going to use the combination rule. And here's that formula that you've used a few times now. The reason we're using the combination rule rather than the permutation rule is because it doesn't matter what the order is. When we select the 2 movies, the problem doesn't say anything about which movie you pick first, so the order is not relevant. So we're going to use combination as opposed to permutation. Okay, so now the probability of getting 2 movies out of the 4 movies and getting 1 tennis game out of the 3 tennis games is, okay, here's my little handwritten formula here, is the probability of 2 movies and 1 tennis game equals, here it is. It's on the bottom here, that's the number of ways to choose 3 activities out of 9 activities total. This is the way we always do it, right? It's the sample space is in the bottom here, is in the denominator. Here's these formulas. Oops, wrong one, sorry. Okay, so in your textbook you have these formulas, right? So like the fundamental formula for classical probability is right here. It's the number of outcomes in the particular event. So the probability of some event is the number of outcomes in that event over the total number of outcomes in the sample space. So that's a formula that you were given. And as I mentioned here, it's on page 189, I think. This is so much harder than it looks. Okay, so that formula is explained on page 189, but it's also at the end of the chapter, it's all the formulas are on one page. Okay, so the number of ways that we can choose 2 out of the 4 movies, that's 4 choose 2. That's in the numerator, and then in the denominator is the total number of ways in the sample space. That's the number of ways to choose 3 activities out of 9 activities total. So that's 4 choose 2 over 9 choose 3. Okay, that's the probability of getting 2 movies out of the 4 movies. Here's the probability of getting, this is the number of ways up here, that's the number of ways to choose 1 tennis game out of the 3 tennis games. So it's 3 choose 1 games. And then here again, same as before, there's 9 activities. How many ways can you pick 3 out of the 9 activities? So this is the basic formula that we would use to do this calculation. Okay, and let me also mention that In your book, page 242, this is example 4-51. So 4-51 has very similar to this type of a situation. Okay, so let's get back here to the problem. Oops. Okay, so the numerator, excuse me, the denominator is the same. So you multiply the two top guys, the two numerators. Okay, so multiply this times this over this. So, it's just a matter of applying the formula, which hopefully you've done a few of these, so you know how to do these. 4 choose 2 is 4 times 3 over 2 times 1. 3 choose 1 is 3 over 1. 9 choose 3 is 9 times 8 times 7 over 3 times 2 times 1. Crank all of that out, and you come up with 18 over 84. You can do a little bit of factoring here. 18 is 3 times 6. 84 is 6 times 14. The 6's will cancel. That gives me 3 over 14. I'm giving myself a big happy face because that is the correct answer. Okay, so I hope that helped you.